You're kidding me. Well,
Okay. Why is it still there?
it's here with you.
Okay, guys, grab your formula page that I gave you, I think on day one when we did parametrics. I just want to add a couple of things to this or make a couple of notes on this page. So look in the middle of this page. You have these vector position, velocity, and acceleration vector notation. I just want you to make a note that this is simply vector notation for a set of parametric equations. Okay. The only difference is you've got these, what do you call these? Little
Angle brackets.
Okay, angle brackets. That's a good name. I like that. Angle brackets rather than parentheses. So obviously your x of t, y of t is the position. X prime, y prime would be velocity vector, and double primes are going to be your acceleration vectors. Okay. Now go down to the bottom of the page. This is the formula we're going to be using today because we're going to talk about speed. Okay, remember that as your parametric graph is being traced out, like we did on day one, your horizontal speed would be x prime and your vertical speed would be y prime, like a particle motion. Okay, so your speed is going to be the square root of x prime squared plus y prime squared. And if you hopefully maybe remember from pre-cal, that's the magnitude or the length of that velocity vector. And then later on in this unit, we're going to talk about arc length. And all you do to get arc length is just integrate your speed. Okay? The arc length of or the distance traveled of your particle. Okay? Awesome. So this is the formula that we're going to be using today, working with speed. All right. So today is parametrics and speed. Title of our notes, parametrics and speed, right there. All right, so let's look at our notes problems. They gave us the speed equation at the top. It says speed tells us how fast the distance traveled by the particle increases with respect to time. So the very first one, notice it has 2 stars. What does that mean? It's off of an FRQ. Okay, so number 1, and it is calculator, so you definitely need your calculator today. All right, so here's what it says. The particle moves in the xy plane so that its position at any time t is given by this set of parametrics. So write these equations down. X of t is equal to t squared, and y of t is equal to sine of 4t. And they're asking us for this problem, what is the speed of the particle when t equals 3? We're looking for speed at t equals 3. So we're going to use our square root of, but we need to get x prime and y prime. So let's figure out what x prime is. What's x prime? 2t. Awesome. And y prime? What's y prime? Yep, 4 cosine 4t. All right, well, we want the speed at time t equals 3, right? So then I want x of 3, or x prime at 3. What's that? 6. And then y prime at 3 is going to be whatever, 4 cosine of 12. Yeah. All right, so that's what I'm going to put in my square root and square it. Okay, so you're going to grab your calculator and you're going to go speed is going to be equal to whatever the square root of 6 squared plus parentheses 4 cosine 12 squared is. Take it out 4 decimals for me. So given the fact that this was part of an FRQ, I would state my answer in a sentence, okay? Whoops, sorry. What do you think? Not bad? Okay, let's look at number 2. Look at the picture. This was in the FRQ too. And it's calculator, thank goodness. The position of a roller coaster car at time t seconds can be modeled parametrically by these two equations. Okay, so here's our equations. X of t is equal to 10t plus 4 sine t. And then y of t is kind of gross. It is 20 minus t times 1 minus cosine t. Then it tells us what the derivatives of those are. I mean, we could get the derivatives, but it gives us the derivatives, okay? And it says, find the time t at which the car is at its max height. So we need to find that first. So look at the graph they've given you. They've given you a graph that models the path and the height at t seconds, okay, of this roller coaster. It wants to know at what time did it reach its max height. Well, if this is the path of the roller coaster, right here is its max height, right? This is your x of t, y of t graph, okay, together. Are you with me? Okay, so if I want that height right there, isn't that where height would be your y, right? Your y is your vertical position. So that height would be where y prime is equal to 0, right? You with me? The rate of change vertically stopped. It's 0 at that height right here, okay? So you would need to find the first time that y prime is equal to 0. How can we do that with our calculator? Graph what? Graph what? Y prime equation. And then find the what? Find the 0. Find the x-intercept, the very first one, because that's going to give you the time that the roller coaster was at its max height. Ready, go. Do that for me. I'm going to write down the x prime and y prime equations that they gave us. So at what time t did we find that t value? I would like for you to take that out 5 decimals. You can store it, but we're going to be using that number in the next part of this question. I don't want us to round early. Okay, y'all know that, right? You can either store it or take it out 5 decimals, and that'll take care of that. What did we get for the t value? 3 point something? 02391.
Yes.
Is that what y'all got? And that would be seconds. They gave us units on this problem. So far, so good? We good? Okay. They wanted to find us to find the time when the car is at its max height. Now I want to know the speed. How fast was it going when it got up there? Okay, so I want the speed at that time. How can we do that? There's a couple of ways you can do this. We have our x prime equation and our y prime, right?
Yeah, find x prime of 3.02 and y prime of that as a quadrant.
Okay. What do you think would be a fairly easy way to do that? Because you can use this equation and this equation, or you can use this equation and this equation. Because can't we find the derivative at a point? Math 8. That gives us derivative at a point, right? So we can find what this is at this value by just using Math 8. I would store that value. I would store it in A, and then find the derivative of this at this, store it. Then you can do square root of a squared plus b squared if you stored it in A and B. Does that make sense? Or you could just do the whole long here, right here. This huge thing is where I just took that x prime squared, y prime squared, and I plugged in that 3.02391. It's going to take a long time to do that in your calculator. And you're going to have to be sure you close off parentheses correctly before you square it. So there's some silly little errors that we can make if we do it this way. But I chose to do it this way. Use Math 8, derivative at a point. And I stored it in, I stored this one in A and this one in B, and then I just square root of A squared plus B squared. Boom. Let's see if we both get this, depending on which way you use. I do want y'all to plug and chug through that on your calculator. And see if you get, oops, sorry y'all, copying that. Y'all remember how to store, right? With the alpha A, alpha B. And we would need to label our answer because they did give us units in this problem. So your speed would be meters per second. Remember, if you're doing Math 8, derivative at a point, we're using our position, our x of t and y of t equations, right? Thumbs up if you get this answer, 6.0276. Did you get it? Awesome. That's it for notes today, y'all. It's always nice. How do we get? How far did we get on our delta math last class?
The first section, because the second section was with the vectors.
Okay, okay. But are we okay with the vectors? Just knowing it's really just a notation thing. Yeah. Miss Grace, pardon me?
Would you have to like write that you're storing certain values in your calculator?
If in your work you write A and B, then somewhere in your work you need to put, that x prime at this equals this, and make a note that you stored it in A, if you're going to use A.
Okay.
I don't know that I would. I might write this. I would probably write this instead of A. You know what I'm saying? Yeah. But yes, you can use it if you say what it is. Miss Grayson, did you want them to go over their tests?
Yeah.
Okay.
So I have your test for